The shifter that we need for our data path could be implemented using the shift registers in a simple way, but that would require spending some time, few clock pulses, in order to perform the shifting operation. In order to load the shift register, then shift it, and then pass the data to the output. It will require a couple of clock pulses. However, if we do it using combinational logic circuits, it will take less time. In a single clock pulse, we can do the shifting operation. And over here, you will see how it is done indeed, how we can use combinational logic circuits in order to perform the shift operation. So here we have the parameters. For the direction, we will have either towards the left or towards the right. We can also determine the number of the positions, whether to shift with a single bit or one position. So we can have 0 and 1 positions, whether not to shift or shift by one position, or we can have multiple bit shiftings, shift from one position till n-1 positions, or shifting from 0 to n-1. So 0 means that don't shift, and n-1 means that shift by n-1 positions towards left or towards right. In terms of filling the vacant positions, there might be several different options depending on the instruction set, but over here we will usually do the 0 fill, or we will provide the input lines for the vacant, for filling the vacant positions. The shifter could be indeed implemented using a set of multiplexers. In this example that you can see here, we have the 4-bit basic left-right shifter. 4 multiplexers are used, so we have 4 of them. What you see here is indeed that we have the 4 to 1 line multiplexer. We are using 4 of them. Since we have a 4 to 1 line, it means that for the select inputs, we would need to use 2 lines, S0, S1, for example. Yeah? The select line is common among all of them, so all the multiplexers receives the same select lines. The important thing here is the way in which the input lines of the multiplexers are connected. So if we say that S1, S0 is equal to 0, 0, it means that for all the multiplexers, the first input will be considered and it will be provided at the output. So the first input will pass to the output side. And I think you could see it over here. Yeah, when we have it, the first input is B3, B2, B1, and B0 for our multiplexers. So when this is the case, as the output, or H3, H2, H1, H0, we will have B3, B2, B1, B0. And obviously it means that no shifting is performed. Yeah? The B is passed unchanged. While if we have S1, S0 equal to 0, 1 as the next example, or as the next case, the second input of the multiplexers will be selected and it will be connected to the output line. And now you can see H3 will be equal to IR, H2 will be coming from B3, H1 will receive value from B2, so let me write them maybe. Over here we will have IR, this comes from B3, B2, and this will come from B1, you can follow it. So in this case, H will be IR, B3, B2, B1. And I think you can see the shifting, shifting of the content of B towards right by 1 bit position. And then filling the vacant position with IR, which is the serial input to the for shifting towards the right. Then if we have S1, S0 equal to 1, 0, the third input will be selected. Let us see what will happen in that case. The third input will be selected and it will be connected to the output of the multiplexers, and then we will have at the output side of the multiplexer we will have, so this one comes from B2, this comes from B1, this comes from B0, and this one comes from IL. So H will be equal to B2, B1, B0, and IL. And you can see that the content of B is shifted towards the left by 1 bit position. The case of S1, S0 equal to 1, 1 in this case is not used, but in general it could be used. Yeah? So this is a simple example of how the multiplexers could be used in order to perform this kind of shifting operation towards right, towards left, or not changing the input. The next kind of shifter that we could use is called the barrel shifter. The barrel shifter is indeed rotates the data within the, let's say, within a register. Yeah, it receives the data in the form of 4 bits, D3, D2, D1, D0, and then depending on the select inputs, it rotates the data within it. You can see that it is also constructed using 4 multiplexers. We are using again 4 to 1 line multiplexers. All of them are receiving the same select inputs. These are the select inputs, S1, S0, and you can see that all of them are connected to the same S1 and S0, to the main ones. Then depending on the case, we can follow it. And let's see, when we have 0, 0 as the S1 and S0, in that case the input number 0 for each one will be selected. You can see that input number 0 for the multiplexers is connected directly to D3, D2, D1, and D0. So no rotation will happen. While on the other hand, if we have S1, S0 equal to 0, 1, the second input will be selected. Let's see where it is connected. So this one is connected to D2. So Y3 will be D2. For this one, if we follow it, we should see that it is connected to D1. So D1 is here. Similarly, for this one, it is connected to D0. And finally, for D3, if we follow it, you can see that it is connected to D3, which is over here. And you can also check it for the other 2 cases. So we have rotate 1 position, rotate 2 positions, and rotate 3 positions. And you can see how the output values are determined based on the select lines. So in this way, we can also construct a shifter in using a combinational logic circuit instead of using the shift registers to have it fast and quick.